So as of now, we saw how to calculate the center of mass of two or more objects of a system of two or more objects that all lie along one axis, along one dimension. And we said that to find the center of mass, we simply take the sum of the product of the mass and distance and divide it by the sum of the masses of the objects we are considering in our system. So now we're going to examine how to calculate the center of mass of two or more objects of a system of multiple objects that lie along a two-dimensional plane, for example, the xy plane. So we have the x-axis and the y-axis, and we have 3 point particles that are located at the corners of a right triangle whose sides are as shown. So we have the following arrangement of our 3 point particles. So point number 1 with mass m1 is found at the origin at the point 0, 0. Point number 2 with mass m2 is found 1.5 units above point number 1. It has 0, 1.5 coordinate point. And the last point with mass m3 is found 2 units to the right of point number 1, and it has the coordinate point 2, 0. So note that we are talking about a two-dimensional plane. So that means when we actually calculate the center of mass of our system of 3 objects, we have to find the x coordinate point as well as the y coordinate point. So we need to calculate a point that has the following formula, the following notation. We have x, y, where this entire point represents the location of the center of mass of our 3 object system. So let's begin by calculating the x coordinate of the center of mass, and then we'll calculate the y coordinate. So we use the following 2 formulas. So, note that these formulas are identical to the formulas when the objects lie along the same axis. So we have x1 times m1 plus x2 times m2 plus x3 times m3 divided by the sum of our masses, so m1 plus m2 plus m3. So, note that all the objects have the same exact mass, a mass of 2 kilograms. So the bottom becomes 2 plus 2 plus 2, which is 6. Now, what exactly is the top? Well, m1, m2, and m3 are all 2, 2, and 2. x1 is the x-coordinate of point 1, which is 0, because m1 is found at the origin. Now, x2 is also 0 because the x-coordinate of mass m2 is also 0. So this is 0. And this has an x-coordinate of 2. So that means we have 0 plus 2 times 2, 4. So 4 divided by 6 is 2/3. So this is the x-coordinate of the center of mass. Now, what about the y-coordinate? Well, the y-coordinate is given by the same formula, except now we replace the x-coordinates with the y-coordinates. So we have y1 times m1 plus y2 times m2 plus y3 times m3 divided by m1 plus m2 plus m3. So the bottom, the denominator remains the same. It's 2 plus 2 plus 2, which is 6. Now the top becomes different. So y1 is still 0 because object 1 is found at the origin. So this is 0 times 2, which is 0. Now y2 is no longer 0, it's 1.5 because the y-coordinate of point 2 is 1.5. So we have 1.5 multiplied by 2. And the final point is no longer 2, it's 0 because this point has a y-coordinate of 0. So we have 0 plus 1.5 times 2 plus 0 divided by 6. So 1.5 times 2 is 3. So we have 3 divided by 6, and that reduces to 1/2. So that means the center of mass, the location of the center of mass on this xy plane is given by the following coordinate points. So we have 2/3 is the x coordinate and 1/2 is the y coordinate. So if we label it on this diagram, we have 2/3 units to the right along the x-axis. So let's say that's somewhere right here. And 1/2 units up. So let's say that's somewhere right here. So that means this represents the point of the center of mass. And if we represent it in vector notation, well, that simply means that our vector is given by the following point, 2/3, comma 1/2. So this is our center of mass vector CM.